that size gonna make it in stream, probably. So we're now waiting for something to fall apart. Give me a moment to make sure that we're coming through, and we seem to be. Excellent. So, this is being streamed the night after I published my rant about the horrors of a Canon 800D, and in order to rule out possible issues, don't get me wrong, the camera still has issues, so I'm probably going to have to warrant to return it again, but in order to prevent further issues in the future, we're going to be upgrading the battery grip slightly. So a possible issue with this thing is that the leads going to the pack are relatively long and not very thick. We have perhaps a total of 10 centimeters of lead going from the top of the connector there to down in the actual cell area where the protection circuit is, roughly here. And that's going to have a bit of an impedance to it, which could potentially cause the camera to not receive enough power. I think it's unlikely. I do not believe that's to be an issue, but just to be on the safe side, I've got a tiny cap here which I'm going to try and install right at the top of this battery case. And let's see if we can get a bit closer in there. It is rather cramped, but it should be somewhat doable. Very somewhat. If we just really squeeze it in there, it could work. So I've kind of pre-started. I've taken out one of the connectors. These are not really used for anything at all, since they are just for the data and they're obviously not connected. Right. People are starting to show up in the chat. Soft Machine says, a fellow 800D owner here. I am truly sorry for your loss. I am not happy with mine. But then again, the gods seem to have determined that I am not to operate cameras, since every single camera I seem to purchase has some horrible issue. And the one you're watching me through right now, the €700 Panasonic HC VX980, only shoots 50p. It doesn't shoot 25p, which is what I want. The 800D obviously doesn't work right. And my old crappy camera, well, that's an old crappy camera. Let's not lose our screws. So this is a battery pack, which is live. There is no on-off switch on this. Are we underexposed? No, we're not underexposed. My monitor's just crap. Soft Machine says, mine's great so far, but I pretty much only shoot stills. Well, I can't bloody well shoot stills properly on mine now, since the live view autofocus is so horribly broken. It's broken in video mode, and still mode makes no difference. And it keeps writing random files to the memory card, but I'm thinking I'm going to save some of those files and upload them somewhere, just in case some Canon hacker will have use for them. So let's just see how much voltage we've got in this battery, in case we're going to exploit ourselves. Yeah, that's 7.7 volts. Well, that's not very charged. That's a good thing. So, oh yeah, what's the polarity? I think I usually use the colored wire for positive. And that is the case, the white one is negative. Oh god, something was making a horrible looping noise. I thought the PC had crashed. But it was just the soldering station. Soft Machine says Canon will probably come out with a firmware update at some point soon. They usually do in the early life of their DSLRs. Well, I would hope that they do, because currently there is no firmware updates at all available for it. So I can't even download something and reflash it. I'm going to try and ask for just a firmware file from the support so that I can just reflash the firmware essentially without having to actually send it in for another 3 weeks. Which I would rather not do. Where'd my coffee go? That's my coffee. So this stream is not particularly well planned, I just started it rolling. We're going to try and add a little capacitor without blowing ourselves up. And which direction does this actually go? Have I ruined everything? I've got no idea which way around this is supposed to go. Like so. And it goes like so. So the positive goes that direction. So we're going to have to pretty much solder this cap right onto there. There's not a lot of space at all to move around. Not in the slightest. And we are grossly out of focus since this is a very tall product. Oh well. I am not trying to manually focus this camera, sorry. So I'm just gonna crop one of these leads rather short. Like so. And this is tricky. I'll probably need to bend that out ever so slightly. Where are my tweezers? Expensive tweezers. And this out of focus thing is bothering me. Let's brace for doing. 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 And we will focus slightly higher than this thing wants to. Let's shoot for something like that. That should be slightly better. There we go. That looks better. Now I'm going to forget that. Someone asks why a capacitor. It is to lower the impedance of this battery rather than the terminal when the camera is trying to draw big current spikes, so that it actually has a chance to receive the power it needs to receive without crashing and misbehaving. That's going to go in there, and this is going to go on there. Yeah, that's going to work decently. I have a bit too much lead. Yeah, that's going to work. That's going to work reasonably well. So I will now proceed to find my solder. I'll just try and put it on there. Once I'm done with this, we might actually try and see what the ESR of this battery pack is, because I actually haven't tested that. I just kind of assumed that it was going to be low enough for the camera anyway. This still looks out of focus. I'm going to fuck around with this a bit more. There we go. So I'm just gonna add some solder onto these. And hopefully I can just tack the cap on there with pretty much no drama. And there's the part where I managed to short the entire pack out. In fact, I'm going to have to pretty much have it pushed up like so. I'm going to want to bend this lead over so that it's actually going back, because this is just such a tight fit. Rector Magnificus asks me to pause because he needs a smoke, and I'm afraid I'm not going to do that, because I don't need to have a piss yet. I'm probably going to have to have a piss at some stage, so hang in there, and I might. That's decent. We will bend this like so. Let us attempt to solder this in place without shorting everything out. This is fidgety. Very, very fidgety. I don't want to use any metal tools around here since we do have a live lithium packet. I'm gonna horribly burn my thumbnail, but it's worth it. Just need to slightly tack it. Did that get tacked? No, it did not get tacked. There we go. That is tacked. And now we can actually solder the other lead and then redo that more properly. Spark, that's a good thing. It is not exploding, so we have turned it the right way around. I'm going to have to use metal tools for this. There's no way to get around it. Ah, crap. I do not want to have this lead floating around. That is not a good thing. Oh god. I do not... Nah, don't short out, please. I do not want to fry my protection circuit. Broken protection is very, very bad. There we go. Oh dear, we are almost out of frame. Nothing wrong with something being tight. That is a pretty decent point. Well, it does heavily depend on context. So that's a cap kind of installed. Let's reflow the positive lead just to give it a bit of a better solder joint, because it did not quite adhere as well as I wanted it to. There we go. If we are lucky, this will fit into this hole. Which way around does this go? Have I made a mistake? It goes that way around. I have made a mistake. That is not going to work in the slightest. That is entirely wrong. Because there's a little bar here which is entirely in the way. So that's not going to be any good. Oh dear. What was I thinking? So I'm just gonna chop a piece out. Yeah, it's probably easiest to just chop this piece out. This thing is sturdy enough anyway. Do I want to do that? How are we going to chop a piece out? Tissing says hi from the middle of nowhere in Alabama, US. Hello, Alabama, US. Is Alabama a redneck kind of state? I have no idea. This is a dilemma. I can kind of fit the capacitor in there if I really rearrange everything, but it's such a tight squeeze in every way. And it really is going to be conflicting with the contact leads, which are sticking down in there as well. So I think we really, to get a capacitor this size, I really want 100 microfarads in there. We really can't get around chopping a piece out. So let's just chop a piece out. It does not quite matter. So we're going to just make it fit the way it is sitting right now. So we're going to chop from pretty much there to pretty much there. Bring in the crappy Knipex pliers. Chop. Chop. Oh dear. That cracked in all the wrong ways. Oh well. This is some properly glass fiber reinforced plastic. This stuff is a lot tougher than you would expect. I keep getting pleasantly surprised by this Mikey battery grip. Oh, and this plastic, it feels closer to like Milwaukee drill plastic, ow, than it does the cheap Chinese knockoff product plastic. It's very impressive. Oh. That's gonna ruin these Knipex pliers even more. I don't care because they are surprisingly bad. Is this gonna fit now? It is not going to fit because I haven't chopped out enough. We will proceed to chop out more plastic. Snap. Break. Snap. Oh. Break. Not getting that out properly. Easily. Something like that. Have a pretty decent chunk missing there. Hey, was Alabama a redneck state or not? Did they reply? Let's just read some comments. You can remove some of the plastic in the housing. Indeed. So what was the amplifier again that you converted to analog specifically? It says so in the comments, in the title of the latest video I just uploaded like half an hour ago. It's a NAD T748. I've got a couple of more amps I'm hoping to have time to convert soon. Alabama has the headquarters of NASA, okay. You can be a redneck rocket scientist though. You're not going to put this in the camera that does not work properly, are you? That is the only camera which this fits in. So yes, I am going to do that. The Cool Potato says, I'm happy to see that CRT monitor in the background. I am looking to get one for myself. The GDM FW900. Really, the Sony CRTs are pretty trashy because they have awful gamma response. They have a native gamma of like 2.4 to 2.6, which is pretty much useless. They just look very, very, very dark. And if you try to defeat it, it just turns into a horrible grey, mushy image like an old LCD is what it turns into. Snap. We don't need no plastic. How's this going to work? Oh yeah, I think this doesn't actually go that far in this because we have this little cover. Oh no, actually it does. But that works. That's decent. That's just fine, really. Huh, almost stylish. Excellent. Have I broken it? Have we shorted the protection circuit out so that it no longer works? Let's find that out. That probably made a horrible sound. We have not broken it. We've got 7.7 volts there still. I wonder how I've managed to empty this battery so deeply. I don't feel as if I've put that much use on it. Charged it rather recently. Perhaps the camera started to draw current while being off again. Okay, so let's just put this together. Let's see if it still works. See if we can power the camera with it. This could be useful also for just to tap in a voltage reading out of this at some stage without having to take the whole pack apart. Where's my screwdriver? Where's my coffee? Where is my screwdriver? There's my screwdriver. Someone's asking for advice how to just basically use a multimeter. If you don't know how to use a multimeter, consult like Dave Jones's old videos, EEV blog. I think he has some decent tutorials on that stuff. Or just search YouTube for how to use multimeter. Surely someone has made videos about that, and those are the wrong screws. Which are the right screws? Those are the right screws, I hope. Someone says tape it, someone says don't tape it. I'm not going to tape this. Not yet. It's a handy little access port, because I really do want to, at some stage, add a battery indicator on this thing, since Canon are evil twats and they do not allow you to get any kind of battery indication on a pirate battery. None at all. So this will just bolt in. Will it bolt in? I'm absolutely mongering these leads. There we go. That ought to be reassembled. It's a good thing that I removed these two contacts, because that's going to leave less contact pressure. Or that's going to leave a slightly more contact pressure on these two, since there will be less force trying to push this out of the camera. Which is good. Let's check again just to make sure we haven't destroyed this. Zoom. Nope. Well, that is not as charged as I thought it was. Not in the slightest. That's weird. I really hope this camera hasn't started drawing current again, but let's just try and hook this up and see if it works. Here comes a lot of money of a broken camera. I have not managed to fuck the polarity of this up. I want to really double check this. Just to absolutely be certain. Because I'll put a broken battery in. I'm pretty sure the warranty will not cover it. So positive to positive, is that labeled correctly? I'm just going to cross-reference that with an original battery, just to be 100% certain. Enter Jesus, and we've got negative, positive. It correlates to what we've got on the case. And that correlates to what I see on the meter, but you don't, so that's fine. Alright. Let's see if it's happier. Well, it's not going to be happier, because whatever's gone wrong already has gone wrong. And I really do not think it's got anything to do with a battery. Battery communication error, no, yes. And it runs, but it's still gonna be fucked. Let's see. One shot AF. And now it is just not going to focus. Nope. Just look at that. If we... There we go. So... oh, fuck's sake. Press the focus button. It fails. Every time. Let's see if the touch focus is going to work. Nope. Touch focus is not going to work either. Let's see. Where are our... oh, this is confusing. We'll just... that's the button. Let's do... single point AF. Single point AF. Live view. Is that going to focus? Nope. It's ridiculous. It just slowly draws the lens out of focus. I'll just manually manga that to the other end. And you can see, back to autofocus. Press the shutter button, it goes in focus, out of focus. Ugh. What a piece of trash. What an utter piece of trash. But let's just get this apart. Well, get the battery off and see if we can do something to check the internal resistance of the battery. Because I am curious. Granted, this battery is not really charged, so it's not going to be a fair test whatever we do. But how are we going to do that? I don't have any really suitable adapter which is going to fit this, I do not think. I don't think this adapter is going to fit, but it could be worth an attempt. Oh, that's the wrong adapter for this application, but if we try and... yeah, no. That is not happening. That's not happening at all. So, I'm just gonna wrap some... I'm gonna connect up the resistive load to my multimeter leads, and we'll just poke the battery terminals with the multimeter leads and see what happens. Because we have, what's that, 7.7 volts open circuit on this thing. 7.72. So if I just take an 8 ohm load, clamp it across these probes, and we can at least load it down, see how it behaves. That gives an estimate. Just to, you know, see if the battery's entirely fucked. I don't think it is. I really do not think it is. These leads are just long enough. We've got 8 ohms across these guys. And I can prove that to you. Eight ohms. So we'll just clamp those on there, and we can just see how far the voltage drops on the load. This is not going to give us any kind of test of the actual impedance of the battery or anything. Oh, can we get rid of that horrible glare? I don't think so. Place your bets what the voltage is going to be. 7.5. That's 0.2 volts of drop. 7.46. Okay, let's try and do a kind of correct calculation. So 7.43, I'm going to switch this to 4 ohms. 7.22. 7.44. 7.2. 7.43. 7.2. And it drops from 7.43 to 7.2. And there is a way to calculate the ESR from the voltage and voltage drop, if I can remember. Yeah, if you divide the delta voltage with the delta current, you will get the impedance. So I'm just gonna screw around on my computer for a sec, and we'll derive those values. So the initial, hang on, let's see if we can, I think I have dig out my my material for the Canon battery test, which I no longer have. I no longer have that on online storage, so screw that. Screw that! I'm going to call the impedance of this battery at its semi-charged state to be 260-ish milliohms, which really is acceptable. The camera should be able to run just fine on... Audio is gone. Oh dear. That is... yeah. I know, I'm sorry, I know why the audio is gone. That's because I haven't added the HDMI capture to the scene. Give me a sec, I'm gonna add... Okay, we should now have audio, and if I just hide that in the back. Right. You should now have audio on this scene. I really hope. Let's verify that, because I don't trust this software. Do we have audio in this scene? We do have audio in this scene, good. Sorry about that, so let's just run through the calculations. So, to calculate the internal resistance of this battery, you divide like the way I do it is I switch my load, I connect up, let's do this, I connect up the camera, or rather the battery, to this load, and I apply a static 8 ohm load, and then I swap it to 4 ohms and measure the difference in voltage drop across the battery, because we get a much higher current at 4 ohms. So I took that difference in voltage and calculated the difference in current and wrote it down there. And then I divided the difference in current over the difference in voltage. No, the difference in voltage over the difference in current, I believe, in order to derive the internal resistance of a battery, which ended up to being about 260 milliohms. This is not very accurate at all. It's going to be within like 20% or something, since we don't have accurate gear at all. But it gives us a ballpark number. And I used this this technique to derive the ESR of the whole bunch of cheap internal batteries I got for this camera. And I tested it in a simulator, it works just fine. Yeah, it's just theory. Oh dear, I'm trying to set fire to my leads. Whoops. It works just fine to get a rough ballpark. If I had a more accurate resistor, or if I had more accurate everything and bothered to take better readings, I could get pretty decent results, but it's ballpark. This has, at its now roughly 50% charge level, has an internal resistance of about 260 milliohms, which is good enough. I believe the original Canon battery had an impedance of about 150, and the bad Chinese ones had closer to 300, so it's not super good. And while you would expect a giant battery like this to actually have a very low ESR, that is not going to be the case, since we have a whole bunch of wiring in here, because the cells end right there, and there's wiring and double protection circuits and stuff running up here, and this cable run is what's adding the extra internal resistance to this battery, and that is why we've added the capacitor up here, because that's going to give us a much lower instant ESR. As long as we are discharging the cap, drawing short pulses of current, we're going to have an ESR for like 100 milliohms, less than that, 50 maybe, compared to the almost 300 we get during continuous load. But the continuous load is not an issue since we have, well, a very strong voltage source down there, so it's not going to drop a huge amount anyway. Yeah, so there you go. That is a capacitor added to the battery for the broken camera, and a test of how well it performs. And if you want to see how well this original battery performs, you can dig through the channel. I've got a video about shooting out a bunch of these batteries, and I actually tested the internal resistance of this battery in there. And that's about it. I need to get back to playing with this thing, the giant touchscreen PC, which I'm just about installing Windows on, and trying to get to working without the horrible proprietary software it came bundled with. So, thank you for watching. Cheerio.